Welcome to all of you in Sankalp Education Pratham classes. I am Sachin Patel delivered lecture on rotational dynamics. Right now in this lecture we are going thoroughly with the vertical circular motion, that means V.C.M. In V.C.M you will get the two types of V.C.M. First is a controlled V.C.M and second one is a V.C.M which controlled by gravity. That means here the vertical circular motion is completely controlled by gravity, and controlled V.C.M in which we are going with a speed is either constant or not controlled by gravity. In this case V.C.M has either speed constant or not controlled by gravity. For example, we have to consider here a giant wheel is there. Example of this is a giant wheel. We know that in giant wheel, wheel driver is going to push the wheel, and you are moving upward direction. You are moving upward, downward, upward, downward, upward, downward. In this way we will get the controlled V.C.M, and we also get the giant wheel inside which by using a motor you can control the motion of that vertical circular motion. In this vertical circular motion giant wheel, we can start from the anywhere, and you will give the controlled energy to the wheel, and therefore it moves with constant velocity or not controlled by gravity, in which you will put the energy to that wheel, and therefore it is a move upward, downward, and so on. So then you are going with the vertical circular motion which is controlled by gravity. In this vertical circular motion we supply energy at lowest point, and there is inter conversion between kinetic energy and gravitational potential energy. That means what? When we are moving in upward direction, first of all we have to moving from the lowest point, where lowest point you will supply the energy at the lowest point. After that, this energy is provided at the lowest point, we have to move in upward direction. That means your kinetic energy, that means you have provided the energy which is nothing but a kinetic energy which is converted into the potential energy. We know about the kinetic energy. It is energy due to velocity, and potential energy is energy due to height, or it is a position of that particle. And therefore when we are moving in upward direction, at that time our velocity is decreases and your height is increases. Therefore kinetic energy is converted into potential energy at the topmost point. When we are moving from the topmost point to downward direction, at that time your potential energy is converted into kinetic energy. That means it is nothing but interconversion between kinetic energy and gravitational potential energy inside the vertical circular motion which is controlled by gravity. And controlled V.C.M in which we have to get the vertical circular motion, either speed is constant or not controlled by gravity. For example, we have to get the giant wheel is here, and vertical circular motion in which controlled by gravity, you just provide the energy at the lowest point, and those energy is interconverted in the kinetic energy and gravitational potential energy. Right now we are going with the next point related to that vertical circular motion is a point mass under vertical circular motion, undergoing vertical circular motion under gravity. That means it is controlled by gravity, and it has two cases. First case is a mass tied to the string, and we have to see in next lecture related to case second, which is nothing but a mass tied to the rod. And now we are going with the case first is nothing but a mass tied to the string. In mass tied to the string, you will get the consideration like that one. Later to consider it is a vertical circular motion in which a mass is tied to the string, and this is the lowest point. That means it is a point B is here, lowest point. This is the highest point, that means top point. That means lowest point is a B is here, and you will move up. At that time you will get the highest point. If move down, you will get the lowest point, that means B, and so on so. And therefore you will get the point. This point is a top point A, this is the lowest point B, this is the midpoint, and it is denoted by D. It is denoted by D. This point is C. This point is C, which is the midpoints of that particular vertical circular motion, in which later to consider this point is represent the position of mass which is tied to the string, and this is the center of that circular motion, or say vertical circular motion. It is considered not in a horizontal plane, you will consider it in a vertical plane, and therefore this point is become a lowest point, and this point becomes a top point or highest point, and those 2 points are nothing but a midpoints of that one. And inside this we will take the consideration of mass tied to the string, and we have to describe first of all Bob tied to massless inextensible string, and reeled in vertical circle. At that time, any position of the verb, those are the position of the verb. This point is nothing but a D point. D point is here. This point is nothing but a point, which is a topmost point. C point is here, and B point is here. It is the lowest point. Midpoints are there, and those are the this is the one highest point in the vertical circular motion, which is not in horizontal. We have to take it in vertical, and therefore this is the lowest point, this is the highest point, and those two are midpoints are here. And Bob is positioned by point A, point B, point C, point D, and here we have to join the string, which is and where you will get the any position of Bob. Two forces acted on it. First is a weight mg in downward direction, and the second is a tension along string. This tension along string, it is changes by location, and we have to take the consideration location and period. That means we will think about the time period, or it is a time related to that one. First, once again, you have to going with the case in which point mass point mass undergoing vertical circular motion under gravity, in which you will get the two cases. First case is a mass tied to the string, and second case, which is discussed in the next lecture, which is nothing but a mass tied to the rod. And here, when we are to going with the reel, when bob is tied to massless inextensible string and drilled in vertical circle, at that time we will get the B is the lowest point, A is the highest point, and C and D are the midpoints of that one. And at any position of the bob, you will get the two forces acting on that bob is nothing but a weight mg. Weight mg, it is a downward direction here. At D point you will get it is acting a downward direction, at B point it is acting a downward direction, at C point it is acting a downward direction, A point it is acting a downward direction. That means weight acting at any position in the downward direction, and tension along the string, which is a different at a location and a period of time. And that means here at point A, tension in the string is a TA. At point B, tension in the string is a TB. At point C, tension in the string is a TC. At point D, tension in the string is a TD, and which is different locations in a vertical circular motion, where it is given by different value, or it is changes the value of that tension in the string according to location and the period of the time. And therefore now we have to consider this motion is a non-uniform one, and this motion is a non-uniform one. At that time you will get the forces not directed towards the center, except those points is nothing but the uppermost point and lowermost point is there. That means here we consider if motion is a non-uniform resultant of those forces not directed towards center, except 2 points is nothing but a uppermost point, except uppermost point, that is the point A, and lowermost point, that is B. These 2 points where the resultant of these two forces acting toward the center, and all other points there will be resultant of those forces not acting toward the center, and at other positions this is acting in the at other positions it is acting tangential and change the speed. What you can say, we know about the vertical circular motion, inside which once again you have to come here, and at point A and at point B the tension or resultant of these two acting toward the center, and all other points you have to consider this point. Here the resultant of these forces is acting along the tangent is here, and first of all we have to know about the watch which is attached to your wall. Complete observation of the second hand inside the watch. Second hand means second hand of that watch. We know that when watch comes down from 12, that means it is move towards the gravity or towards the floor of your home. At that time it is moving softly, like that one. But after up to, later to consider it is a 12 and it is a 6, here it is moving softly, let it consider whatever be the position, whatever be the direction of that particular point. When second hand it is moving from 12, it moves softly in downward direction, but after 6 it is moving against the gravity, and therefore it is a jerk. It has the jerks like that one. It is moving like that one, from 6 to above, that means up to 12. That means in one direction from 12 to 6, the speed of the second hand is increases, that means it is accelerated, and the speed of the second hand, it is decreases from the points from 6 to 12. That means it is deaccelerated. It is also called as a retarded, and therefore here also we consider the particle is moving in a vertical circular motion. At that time, the resultant of that two forces, which is acting tangential and which is changes the speed of that particle or this mass, which is tied to the spring, and therefore it is moving in downward direction. Let us consider it is moving in downward direction. Here particle is moving in anti-clockwise direction, and therefore from point A to B it is moving in downward direction. At that time it is accelerated. That means speed of the particle is increased from A to B, and from B to A, the particle moves in upward direction, and therefore it is deaccelerated due to that one component is mg sin theta is here, mg sin alpha is here, mg sin theta, which is along the motion of that particle, and therefore it is supported the motion, and therefore it is accelerated the particle when it is moving in a downward direction. But from point B to A, particle it is moving in upward direction. At that time mg sin theta is acting opposite direction of that particle, which is moving in upward direction, and therefore it is a deaccelerated, that means retarded. Those are the two considerations related to that one. From one point to another point there will be acceleration of the particle, and another that point to next uppermost point you will get the deceleration, that means retardation of that particle, and at that time you will get the change in speed due to that tangential components, that means mg sin theta and mg sin theta and mg sin alpha is considered here, and it is a different, this alpha and theta is different at different positions on that vertical circular motion, and therefore you will get the considerations at other position it is acting tangential and changes the speed of the particle. Now we have to consider inside the first of all, one point is here. We have to consider uppermost point is now uppermost point or position. That means A position. We have to know the position A inside the figure. Once again we have to move with the figure is here. At a point position A, it is the uppermost position. The TA be the tension which is acting toward the center of the circle, vertical circle, and mg is a weight which is acting downward direction. That means these two forces acting toward the center. Right now we have to consider at point A, the speed of the particle is VA. And therefore you will get a consideration of at uppermost point, VA be the speed, m be the mass of that particle, mass of the bob, and m be the, let it consider here, m mass of bob, and VA is the speed of particle at point A. VA be the speed of particle at point A, and TA and mg is acting toward the center. That means these two balances or gives the resultant force towards the center, which is nothing but a centripetal force, and therefore you will get the at uppermost point weight mg and tension TA acting towards center as a resultant centripetal force, and Va be the speed at position A. Va be the speed or speed at position A. Let us consider once again is here TA and mg acting toward the center, and Va be the speed at point A. Those are the consideration, and which are at uppermost position. We know that the weight mg and tension Ta acting toward the center as a resultant centripetal force, and therefore you will take the consideration of these two, and you will say that this centripetal force at point A, which is balanced by a resultant two forces which is acting toward the center, that means TA and mg, and therefore at position A, we said that the mg plus TA is equal to mva square divided by r, where r is the radius of that circle where we have to move the particle, and therefore you will get the consideration of those one. That means mg plus ta, which is acting toward the center, which balances or gives the resultant centripetal force mva square divided by r. Right now we have to get the consideration of this one. For minimum speed, we get first of all you have to take the consideration like that one. For minimum speed at A, TA is equal to 0. That means string is start to slack down. That means tension in the string, which is at the uppermost point, is 0, and at that time it is moving in downward direction. At that therefore Ta is equal to 0. Put it here. You will get the consideration of mg is equal to mva square divided by r. M and m cancelled here, and r is transferred here. You will get the va square is equal to rg, and it implies that on taking square root on both sides, Va is equal to square root of rg. This is the minimum speed at the position A. And right now we are going with, it is at uppermost point. Right now we are going with the next point is nothing but the lowermost position is here. Lowermost position. Once again we have to going with our figure, and at lowermost point we will get the consideration of that one is nothing but here at lowermost point B. Now tension TB, which is acting towards the center, and mg is acting away from the center. That means mg is opposite to the tension TB, which is acting towards the center, and therefore these two forces, that means TB is acting towards the center and mg acting away from the center, balances the resultant centripetal force, and therefore at lowermost point you can say that TB is vertically upward and towards the center, towards the center. And another one is a mg acting opposite, that is downward. downward. That means these two forces acting opposite to each other, and which balances the resultant centripetal force, and therefore you will get the equation is TB minus mg, because these two are opposite to each other, and therefore you will get the mvb square divided by r. mvb square divided by r. Now you have to coming from the uppermost to lowermost point. Once again you have to going with the figure is here, and from figure you will get the consideration of this clearance. We have to move from point A to point B. That means the radius of that circle is r. At that time you have to cover from this point to this point is nothing but 2r distance. And when we covered a 2r distance, our position is changes by height to r, and position is changes by height to r. Your potential energy, gravitational potential energy also changes, because potential energy which depends on the position or height of the particle, and we know that the potential energy at height h, we know that potential energy is equal to mgh. Right now height is changes. What is it? Height changes. H is nothing but height is here, and height changes by 2r, and therefore potential energy is equal to mg into 2r. And this potential energy which is at height A, which is changes in kinetic energy, because we have to moving from uppermost point to the lowermost point. That means we have to move from point A to point B. That means we have to move from point A to point B. That means point A is uppermost point and B is lowermost point. That means your potential energy is higher at point A, and your potential energy is lower at point B. That means your potential energy changes from point A to B is nothing but mg into 2r, which is converted into kinetic energy. What is the kinetic energy at point A? Here velocity of particle is va, and therefore kinetic energy at point A is different. That means it is 1/2 m va square. Here kinetic energy is nothing but I am put it in a small here. Kinetic energy at point A is nothing but 1/2 m va square. And similarly at point B we have to take the consideration of vb is the speed, and therefore kinetic energy at that lowermost point is 1/2 m vb square. 1/2 m vb square is here. 1/2 m vb square is the kinetic energy at point B, and the kinetic change in kinetic energy is nothing but kinetic energy at point B minus kinetic energy at point A, and which is a conversion of the potential energy. We know that the interconversion of kinetic energy and gravitational potential in the vertical circular motion controlled by gravity, and therefore you will get the conservation of those one, and therefore we will get the change in kinetic energy. Kinetic energy is equal to change in potential energy. That means potential energy change nothing but mg into 2r, and change in kinetic energy is nothing but kinetic energy at B minus kinetic energy at A, and therefore kinetic energy at B is nothing but 1/2 m vb square minus kinetic energy at A is 1/2 minus 1/2 va square is equal to mg into 2r. mg into 2r. From this equation we have to calculate the first of all 1/2 m are common here, and take outside from take common, and 1/2 m is here inside the bracket. vb square minus va square is equal to mg into 2r. mg into 2r. Right now we have to cancel out m, and m is here. M and m is cancelled here, and 2 is divided here, it is multiplied here, and therefore you will get the VB square minus VA square is equal to VB square minus VA square is equal to 4RG. 2 into 2, that means 4. This is R, and G, M cancel to each other, and therefore VB square minus VA square is equal to this one. But we also know that VA square is equal to RG. Put it inside this equation, you will get the VB square minus VA square is equal to here we have to put the value of this RG, and it is a 4RG is here. RG is minus here and plus on the other side. Therefore, VB square is equal to 4RG plus RG, and therefore VB square is equal to 4RG plus RG. That means 5RG, and VB is equal to square root of 5RG. VB is equal to square root of 5RG. This is the velocity at the lowermost position B. This is at position B. That means velocity at lowermost point is VB is equal to square root of 5RG, and velocity at uppermost point is VA is equal to square root of RG at position A. Here velocity at lowermost position is higher than velocity at uppermost position. That means kinetic energy at uppermost and lowermost position. Kinetic energy is higher at lowermost position. That means potential energy is lower at lowermost position, and at kinetic energy at topmost or uppermost position is lower, and potential energy is higher at topmost position. That means here we have to conclude here in a small consideration at top, that means at point A, kinetic energy is low, and potential energy is high. At lower point, that means B, kinetic energy is high and potential energy is low. Because at the top point VA is equal to square root of RG, which is low, and at lower point VB is equal to square root of 5RG, which is higher, and therefore kinetic energy and potential energy are interconversion at in a vertical circular motion when it is under controlled by gravity, and those are the related to VB point. And from now we have to consider the equation 1 and 2, and later to consider, and you have to find out what is the difference between the tension at uppermost point and lowermost points inside the vertical circular motion. Right now we have to take the consideration like that one. At topmost point, at topmost or uppermost point, that is the point A. We know that the equation at topmost point is nothing but TA plus mg is equal to centripetal force, which is acting toward the center, is a mva square divided by r. This is equation 1, and right now we have to consider at a lowermost point, that is point B, TB minus mg is equal to mvb square divided by r. It is equation 2. From equation 1 and 2, now we have to subtract equation 1 from 2. You will get the consideration of TB minus TA minus 2mg. We have to put the concentration directly because we have to subtract this equation from this equation. That means this equation, first of all TB, then minus mg is here, TA is taking as a minus, subtracted, minus TB TA, and this plus mg is becomes a minus mg, and therefore minus 2mg is here is equal to mVb square divided by r minus mVa square divided by r. Now m divided by r taken common, m divided by r is here, mVb square minus Va square is here, and TB minus TA minus 2mg on the left hand side. Right now Vb square minus Va square, Vb square minus Va square is equal to 4rg, which is already known to you. Here we are going with the equation, and this equation is nothing to Vb square minus Va square is equal to 4rg, which is calculated in the previous point. That means that means we have to get the concentration in the velocity at lowermost point. Right now we are going with the TB minus TA minus 2mg is equal to m divided by r into 4rg, and therefore r is cancelled to each other, and you will get the 4mg. This minus 2mg is taken here, that means plus 2mg, and here TB minus TA is as a consideration, and therefore TB minus TA is equal to 6mg. TB minus TA is equal to 6mg. Right now we have to consider this equation as a third equation is here. Now we have to going with the positions, which is where when string becomes horizontal, that means midpoint for positions, that means positions which are when let us consider it is a positions when string is horizontal, that means point C and D point is considered here. C point and D point is considered here. At that time, force due to tension is toward the center, and weight mg which is perpendicular to it. That means force due to tension is towards center, and weight mg perpendicular to it, and therefore centripetal force used to change the direction of velocity, and therefore here centripetal force used to change direction of velocity, and mg is used to change speed, and therefore you will get the concentration of Tc minus Ta is equal to Td minus Ta, and which is equal to 3mg, and therefore Vc minimum velocity, Vc minimum velocity is equal to Vd minimum velocity, because those 2 points are same here, and which is nothing but a square root of 3rg. It is done by using a value, it is done by using a consideration of Ta and Td, Tc and Td, which is a tension acting toward the center, and mg is a perpendicular, and therefore mg is used to change the speed, and that means the component of that mg is used to change the speed. Like we have to consider, once again you have to going with the figure, and from figure you will get the clear information related to that one. First of all, we have to take the consideration of this point is here TC point, where the tension TC and TD both are equal, and TC is equal to 3 mg plus TA, 3 mg plus TA, whatever the equation related to that one. First of all, here we take the consideration of T1 is a tension acting toward the center, and mg is acting downward direction, and it is divided into two components, mg sin theta and mg cos theta. Mg sin theta acting in the direction of that particle, and therefore it is accelerate the particle when it is moving from up point to the down point, and therefore you have to consider this component which is used to accelerate the particle from point A to point B. And here again we have to consider T2, it is a tension toward the center, and mg which is acting downward direction, which is resolve into two components, mg cos theta and mg sin theta. Mg sin theta which is against the motion of the particle moves from point B to A at that time, which is against the motion of the particle. That means it is oppose the velocity of the particle when it is moves from point B to A, and therefore mg sin theta, it is a retarded the particle. That means retardation is here, deaccelerate the particle when it is moving from point B to point A, and therefore this is the consideration. And right now we are going with the arbitrary points, where we will get the consideration of let me to consider it is one another consideration related to that one is arbitrary position. Arbitrary position means what? The position which are other than point A, point B, point C and point D. At that time you will get the force due to tension and weight are neither along the same line. That means force due to tension and weight are neither along same line nor perpendicular to each other. Therefore tangential component of weight used to change speed and it decrease speed while going up, it decrease speed while going up, that is from point B to A. That means lower point to upper point. When we are moving from lower point to upper point, at that time the speed is decreases. That means deaccelerated, it is retarded. It is nothing but a retardation, and it increase speed while going down, that is from point A to B. That means from point up topmost to lowermost point. At that time speed is increases. That means it is accelerated is here. And those are the considerations related to that one when we take the arbitrary points. And from these you will get the considerations of those, and you have to conclude from that point, and those conclusions are taken right now here. Now we are going with the conclusions. First conclusion is nothing but a first conclusion, equation 3. That means you will get the TB minus TA is equal to 6 mg. This is equation 3. Not depends on not depends on V and R. That means radius of that vertical circular motion and velocity of particle at any position. Those two quantity, on these quantities, this equation is not depends. This is the first conclusion. Second conclusion is a TA not exactly zero, else string will slack. That means TB is greater than 6 mg. That means what? TA is not a completely exactly becomes zero. If it is becomes zero, the string will be slacked down, and therefore the vertical circular motion is completely disturbed. Third one is kinematical equations are not applicable because none, let us consider here is that is none of parameter constant in motion. What does it mean? No any parameter is constant inside the vertical circular motion, because tension, that means then weight mg is resolved into components